This is the last section in this unit, and now we're going to kind of start pulling all this stuff together. And instead of just working with and simplifying expressions, we're going to add an equal sign and solve an equation. And there are really two kinds of equations to solve. The first one are ones where they're set up like proportions. 3 over x equals 9 over 18. And you've seen proportions like this before. When you have a fraction equal to a fraction, that means it's a proportion. So in order to solve a proportion, and this works only when there's an equal sign in between. If it was multiply, I would go straight across, but because there's an equal sign between these, I can solve this proportion by cross multiplying. So 3 times 18 equals 9 times x. So 3 times 18 is 54 equals 9 times x. To solve for x, we're going to divide both sides by 9, so x equals 6. And we can see how that's true. 3/6 is a half, 9/18 is a half, so they are proportional. 6 is the only value for x that makes this a true statement. Now we're going to start in this unit again checking our answers, and the reason I have to check my answer on this one is because I have an x in the denominator. And there's one time when you never want to have a number in the denominator. If I would have gotten 0 for x, I wouldn't have liked it because you should never have a 0 on the bottom of a fraction. It makes it undefined. Let's do another example. x2 over x plus 2 equals 5 over 7. So same thing on this one. We have a proportion. We know that these two fractions are equal. Since they're equal, that means I can cross multiply. 2 times 7, which is 14, equals 5 times x plus 2. And I want to make sure that I put the 5 on the outside and the x plus 2 on the inside. So 14 equals 5x plus 10. So subtract 10 from both sides. So 5x equals 4. So x equals 4/5. 4/5 is the only solution that would make this a true statement. The only number that I wouldn't want is for x to be -2, because -2 plus 2 would give me a 0 here. So if that would have been my solution, I would have stopped. Let's do a third example. 2 over x squared minus x equals 1 over x minus 1. Again, notice there's an equal sign here, and this only works when it's an equal sign. When there's an equal sign, this equals this times this. So I've got 2x minus 2 equals x squared minus x. Since there's an x squared in the problem, I'm going to put one side equal to 0. So I'm going to have x squared. I'm going to minus 2x from both sides, so I get minus 3x plus 2. And this factors to x minus 2 and x minus 1. So x could be 2 or x could be 1. Let's go back and check our answers. If I put 2 in for x, 2 squared is 4, 4 minus 2 is 2. That's okay. 2 minus 1 is 1. That's okay. But watch what happens when I put 1 in. Specifically right here, look. 1 minus 1 would make this whole thing be 0. So since it makes the denominator of this fraction 0, I would say that 1 is an extraneous solution. It doesn't work. So the only value that works for this problem is the number 2. Let's do one more of this kind. 3 over x squared plus 4x equals 1 over x plus 4. So because there's an equal sign, I know I'm going to cross multiply. 3 times x plus 4 equals 1 times x squared plus 4x. So 3x plus 12 equals x squared plus 4x. So x squared plus x minus 12, that's what happens when I subtract 3x and subtract 12. And then to factor this, I get x plus 4, x minus 3. So x equals -4 or x equals 3. Let's go up and test these and see how they work. I'm going to test this one first. So I'm going to try -4. -4 plus 4 is 0. This one's no good. No need to even check it here. Now I'm going to check 3. 3 plus 4 is 7. That's okay. 3 squared is 9 plus 12. That's okay. So x equals 3 is the only solution to this proportion.